Have you ever wondered why ice turns into puddles of water on a sweltering day? Keep watching and you'll find out. On Earth, materials exist in one of three main states of matter: solid, liquid, or gas. Materials can change between these states. When a state change occurs, a substance's property will also change. Maybe not too surprising. However, if the state change is reversed, the substance will recover the properties it had to begin with. Neat. Matter can transition between the three states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangements of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form. These four words describe changes in state. Do you know which word refers to which change? Pause the video, fill in the gaps, and click play when you're ready. Did you get them right? Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization. The opposite of these vaporization processes is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day, those water droplets on the outsides, or the dew on the grass in the morning, or the steamed up mirror after a hot bath, even the clouds in the sky, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now let's think about the transitions between solids and liquids, so melting and freezing. Think of the Arctic sea ice. In the summer, when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice's water molecules and the ice starts to melt. The solid ice becomes liquid water. But in the winter, the air temperatures are colder, and so seawater freezes, and the ice starts to form again. There is less heat energy within the ice, and so more bonds can form, holding it together as solid ice. So far, so good. But did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation. This is only demonstrated by particular materials such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it will turn straight into gaseous carbon dioxide. Liquid carbon dioxide does exist, but it only occurs under very high pressures. Similarly, gases can turn straight into solids when cooled. This is called deposition. Let's check out how much you remember about the changes of state. Pause the video and fill in the blanks. Did you remember them all? Our final thing to discover is that when a material changes states, the mass stays the same. The density changes, so the mass per unit volume, but the mass does not change. Our glass of nice cold Coke weighs the same whether the ice is solid or when the ice has melted. So there we have the changes of state. Just remember that the mass stays the same whatever the state.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our FuseSchool app as well? Until next time.